Hello, and welcome to our video about nuclear fusion power generation. Today, we'll be discussing the latest developments in nuclear fusion research, the benefits of this technology, and the potential it holds for the future of energy production. Nuclear fusion is an incredibly exciting and promising field, with the potential to provide us with clean, safe, and abundant energy. Explanation of nuclear fusion. To start, let's review what nuclear fusion is and how it works. Nuclear fusion is the process of combining atomic nuclei to create a new, heavier nucleus, releasing a tremendous amount of energy in the process. It's the same process that powers the Sun and other stars, and it has the potential to provide us with an almost limitless source of energy here on Earth. Brief history of nuclear fusion research and development. Scientists have been studying nuclear fusion for over 80 years, and there have been many breakthroughs along the way. One of the most significant achievements was the creation of the first controlled fusion reaction in 1951. Since then, researchers have been working to improve the efficiency and feasibility of fusion reactions, and there have been many successful experiments in the field. Benefits of nuclear fusion power generation. Compared to current energy sources such as fossil fuels and nuclear fission, nuclear fusion has several advantages. First, it produces little to no greenhouse gas emissions, making it a clean energy source. Second, fusion reactions produce very little radioactive waste, unlike nuclear fission reactions. Third, fusion fuels are abundant and widely available, which means that fusion could provide a sustainable source of energy for generations to come. Current state of nuclear fusion research. There are many fusion projects currently underway around the world, with the International Thermonuclear Experimental Reactor, ITER, being the most prominent. ITER is a collaboration between 35 countries and aims to demonstrate the feasibility of commercial fusion power. However, there are many challenges and obstacles to overcome before practical fusion power can be achieved, including developing materials that can withstand the extreme conditions of fusion reactions. Fusion reactor design. There are several types of fusion reactors currently being researched, each with their own advantages and disadvantages. For example, tokamak reactors use magnetic fields to contain the fusion fuel, while inertial confinement reactors use lasers to compress the fuel. Safety is also a key consideration in fusion reactor design, and fusion reactors are designed to be inherently safe and cannot experience a runaway reaction like nuclear fission reactors. Fusion fuel and plasma physics. Fusion fuel typically consists of hydrogen isotopes such as deuterium and tritium, which can be extracted from water and other sources. Plasma physics is a field of study that deals with the behavior of ionized gases, which are used to create the conditions necessary for fusion reactions to occur. Understanding plasma physics is essential for developing practical fusion power. The newest technology. On December 5, 2022, researchers used 192 giant lasers at the National Ignition Facility to blast a small cylinder containing a frozen nubbin of hydrogen encased in diamond. The lasers entered the cylinder at the top and bottom, vaporizing it and generating an inward onslaught of X-rays that compressed a BB-size fuel pellet of deuterium and tritium, the heavier forms of hydrogen. In less than 100 trillionths of a second, the hydrogen pellet was bombarded with 2.05 megajoules of energy, equivalent to roughly a pound of TNT. This resulted in a flood of neutron particles, which carried about 3 megajoules of energy, a factor of 1.5 in energy gain. This breakthrough has crossed the threshold that laser fusion scientists call ignition, the dividing line where the energy generated by fusion equals the energy of the incoming lasers that start the reaction. Future prospects of nuclear fusion power generation. While there is still much work to be done, many experts believe that practical fusion power could be achieved within the next few decades. Fusion power has the potential to revolutionize the energy industry and provide a clean and sustainable source of energy for generations to come. Conclusion. Nuclear fusion power generation is an exciting and promising field, with the potential to provide us with clean, safe, and abundant energy. While we still have some way to go before we achieve practical fusion power, recent breakthroughs and ongoing research give us hope for a bright and sustainable future. Thank you for watching, and we hope you've learned something new today.